This is Algebra 1, Unit 5 review. This is really sections 8.1 through 8.3 and 10.1 to 10.3. This first video is a review of 8.1 through 8.3. It's page 497, numbers 1 through 19 odd. All right, so that when you're doing these, you need to follow your exponent rules. Okay, so number 1, we have x to the third times x to the fourth. Remember that exponents are a shorthand way of writing multiplication. So here I have 3 x's, and here I have 4 x's. So together I have a total of 7 x's. So it's x to the 7th for number 1. Number 3, it's very similar. You have b to the second times b to the negative 5th. Remember, when you have a negative exponent, you have to switch it to the opposite side. So if it's on the top, which this one is, and I know it's on the top because there is no bottom, so you have to switch it to the bottom and make it a positive. If it was on the bottom, I would have to move it up to the top. So this is going to become b squared all over b to the 5th. And then from there, I need to reduce. There are more b's on the bottom. There are 3 more b's on the bottom, so it's b to the third. You need to have a 1 left on top, 1 over b to the third. Number 5, this is different than number 1. Here I only have 1 base, the x. I take the exponent on the outside of the parentheses and multiply. Again, whenever you see the parentheses, you're going to multiply. So this is x to the 21st. There were 7 sets of x to the thirds. Next, number 7, end of the third over end of the 5th. This is very similar to the end of number 3. When I do this, there are more ends on the bottom. There are 2 more ends on the bottom, so it's 1 over n squared. Number 9, mn squared times n to the 4th. You have to take the squared and distribute it through. So this is m squared times n squared times n to the 4th, which when you put it together is m squared n to the 6th. Again, multiplying when there's parentheses, adding when there are not. Number 11, the first one, there really is no need for the parentheses, so I'm going to rewrite it without it. X to the third all over x, y to the 4th, times by, remember the multiplication between the parentheses. Now I take this 5 and I distribute it to both the to the x and to the y, so this is x to the 5th over y to the 5th. So there's a couple ways to proceed. What I'm going to do is make this one fraction first, and then I will reduce. So on top I have 8 x's, x to the 8th. On the bottom I have 1x and I have 9 y's, 4 plus the 9. Now I'm going to just reduce this. There are extra x's on the top. There are 7, so it's x to the 7th over that y to the 9th. You cannot reduce those. They are not like terms. So that is the final answer for that piece. Number 13, 5 to the 4th times 5 to the negative 1st. Again, this is a negative exponent. I rewrite it. 5 to the 4th does not move. It does not have a negative exponent. 5 to the negative 1 comes down as 5 to the 1st. So this is now, where do I have more 5s? I have more 5s on the top. I have 3 extra on top, 5 to the 3rd, and that becomes 125. Number 15, anything to the 0 power is 1. Not much more I'm going to say. Anything to the 0 power is 1. 17, I have, remember this is 3 to the 1st. Don't forget that. There's 5 3s, there's 1 3, so that's 6 3s. On the bottom there are 4, so now I'm reducing just like I've done several previous problems here. There are 2 extra 3's on top, so 3 squared is going to give me 9. 19, last one, I see a whole bunch of negatives in there. I'm going to multiply 5 times 4 here first and make that 20 to the negative 3rd times 5 to the negative 2nd. Bring these down, so this is going to be 1 over 20 to the 3rd times by 5 squared. And now it's just a matter of figuring out what those are. So this is 1 over 20 to the 3rd is going to give you 8,000. All right, I'm getting that. You can do that on the calculator, or 20 times 20 is 400. 400 times by 20 is going to be 8,000. And then this is going to be times by 25. And so now we have 8 times by 25, or I'm sorry, 8,000 times by the 25 on the bottom. So again, I recommend you just use your calculator as I do for all these, because you can use it and it's not worth getting it incorrect. So when you do so, you have 1 over 200,000.